Hello again, welcome to another lesson in geometry. Today we are covering section 11-3, surface areas of pyramids and cones. So we have some vocabulary here. Label each diagram as a cone or a pyramid. So we're going to label a couple and then we'll go back and talk about what makes a cone or a pyramid and how they're different than cylinders and prisms. All right, so this first one is a cone. The second one is a pyramid. The third one is also a pyramid. And the last one is a cone. All right, so what's the difference between a prism and a pyramid? So we learned last time a prism has two identical, congruent, parallel bases. Okay, and then rectangles that go all around them, okay, to form a three-dimensional figure. So that was like a square prism. We also could have had a triangular prism, something that would look like this. Okay, so we can have pyramids are similar in the fact that they're named by their base. So this is a triangular pyramid, but we only have one base when we're talking about a pyramid. This is a square pyramid, okay? And all of the sides, instead of being rectangles like they were in prisms, we're going to get triangles. So a triangular pyramid has three lateral triangles that form the sides. Okay, a square pyramid would have four lateral triangles that form the sides. There are four identical ones like this, and they all meet at a single vertex. Okay, so the difference between a cone and a cylinder. So a cylinder had a top and bottom that were circles and a big rectangle that unwrapped around it. A cone just has a bottom that's a circle, and then the top is a single vertex. Okay, and when we unwrap this, we kind of get a rectangle if you rearrange it. We'll talk about what happens later though. Okay. All right, so our slant height, regular pyramid and a lateral face. Those are some related words for slant height. So a definition, the slant height L of a regular pyramid is the length of the altitude of the lateral face of a pyramid. Okay. The slant height L of a cone is the distance from the vertex to some point on the circumference of the base of the cone. All right, so Matthew says the slant height of the regular pyramid divides the lateral face into two congruent right triangles. So you can see this slant height here. It comes from the vertex and comes down to one of the edges of our base and forms a right angle. And it also, for a regular pyramid, it splits that face into two congruent triangles. That means we're probably going to be doing some trig or some Pythagorean theorem to find some missing slant heights. All right. So let's build our vocabulary here. Circle a figure that shows a three-dimensional figure with a slant height of 5. So this one is not a slant height. This does not come down and be perpendicular to the base. So this one's no good. This one's not a slant height. That's a regular height. It goes through the middle of it. That tells us how tall our pyramid is, but not the slant height. You can think of the slant height for a pyramid as like those stairs you'd walk up through the middle of one of the sides of the pyramid. Okay. However, for this cone, we do have a slant height of 5. It starts at the vertex and goes to a point on the circumference of the circle at the bottom. Is the slant height the same as the height of a pyramid or a cone? And this is definitely no. Okay. The slant height is different. That's why we give it a different name. The slant height at the cone on the right is 3 inches. The height is 2 inches. If I was to stand next to that cone, it would be 2 inches tall, but the slant height, if I was a little ant walking up the side of the cone to the top, that would be 3 inches long. Okay. Okay, on our second page, we have theorem 11-3, lateral and surface areas of pyramids. Okay, so a lateral area of a regular pyramid is half the product of the perimeter of the base and the slant height of the pyramid. Okay, so the surface area of a regular pyramid is the sum of the lateral area and the area B of the base. Okay, so in a square pyramid with a base side length S, then the perimeter is going to be 4 times S. If the base of a regular pyramid has a perimeter of 6Q and its side length is 6, the pyramid has Q sides. Okay, so The perimeter is 6 times q, and each side length is 6, so then q is the number of sides it's going to have. So draw a line from each description in column A to the corresponding formula in column B. Lateral area of a pyramid is going to be 1/2 times the perimeter times the slant height. And the surface area of a pyramid is going to be 1/2 times the perimeter times the slant height. That's the lateral area plus the one bottom. Okay, so now why does the 1/2 perimeter L work? Okay, so what we have going on here, let's take a look at this one. The perimeter of this is the perimeter of a rectangle. So if we unfolded it, we have, and laid it out sideways, we would have this perimeter. Okay, and we'll just go ahead and call it a regular pyramid. So this is perimeter as a square on the bottom. So we have 4 even sides. Okay, and then each one of these sides forms a triangle for the lateral area. And what we're looking for is the area of all of these triangles. Okay, so what's the height of one of these triangles? Well, the height of one of these triangles is the slant height. Okay, so what we have are 4 triangles. Okay, and each one has the same slant height. And instead of saying 4 of them, well, let's do it this way. We have 4 triangles, and then the formula of a triangle is 1/2, and then it would be the slant height and then one of our sides here. Okay. Now, if I rearrange this, I could do 1/2 and then L, and then 4 times the number of sides. Well, 4 times the number of sides is just the perimeter. So that's where they get it for this square pyramid. It also works the same for a triangle pyramid. We would just have 3 triangles that are all the same. So when I multiply 3 times the number of sides we had, we'd get the perimeter of the triangle, or pentagon, or whatever it was. Okay. All right. So problem number 1. A square pyramid has a base edge of 5 meters and a slant height of 3. What is the surface area of the pyramid? So what do we know? Well, we know the base of the side length of the base is a square base and each side is 5. And we know the slant height is 3. And what do we need? Well, we need to find the lateral area and we need to find the surface area. So to find the lateral area, you got to first find the perimeter of the base, okay, which is P. And then we need to find the area of the base, which is big B. And then we use the perimeter in L to find the lateral area, and use the lateral area and the big B to find the surface area. Okay, so basically just find the surface area of it. So let's take a look. First, we need to find the perimeter. So the base was a square, okay, and each side of the square was 5. So we have 4 times the side, which is 4 times 5 for 20. All right. So the area of the base would be 5 by 5, which is 5 squared, which is 25. And then we want to find the lateral area. So remember, if we unfolded this square, we'd have 4 equal parts of 5. And each one of those is going to have a triangle attached to it. And all of those triangles have a height which is the same as the slant height. So these are supposed to be a height of 3. All right. So our formula here is just going to be the perimeter of the square, because we could just do all of this all at once, which is 5 times 4 times 1/2 times the slant height. So our perimeter is 5 times 4, which is 20, and our slant height is 3. So 10 times 3 will give us 30 for the lateral area. Now, our final question here is, what is the surface area? The surface area is the lateral area plus the area of the base for a total of 55. So the surface area of this pyramid is 55 meters squared. All right, let's flip it over and take a look at page 3. Okay, problem number 2, finding the lateral area of a pyramid. All right, so same thing as before, except this time we have a hexagon, and that gives us 6 triangles to find the area of all the way around. So we can do our same shortcut where we just find the perimeter, which is the bases of all 6 triangles added up. times by the slant height, which is the height of each of the triangles, and then cut it in half because the formula for area of a triangle is 1/2 base times height. So we're just finding all the bases together as a perimeter. So circle the correct equation for the perimeter of the hexagon base. So that's going to be this one. There are 6 sides on the hexagon, and each one of them is 36 big. So 6 times 36 will give us a perimeter of 216. So the slant height L of the pyramid is the hypotenuse of a right triangle that's included in here. And you can see it. We have the height of the pentagon, the hexagonal prism, and we have an apothem from the center out to one of the edges on that bottom hexagon. So we have an apothem length. What we really need to know is the slant height, which goes from the apothem up to the vertex. Okay, so it splits one of those triangular sides in half. Okay. All right, so we know that the height of the whole pyramid is 42. That's right here. And we know that this apothem in here is 18√3. And we want to find the slant height that goes with it. All right, so we're going to use the Pythagorean theorem to find that missing slant height. So this is going to be 42 squared plus 18√3 squared. So 42 squared will be 1,764, and 18√3 squared will be 972. And if we add those up, we'll find the whole length of the apothem of the slant height is 2736, the square root of. So use the formula 1/2 perimeter times the slant height to find the lateral area of a pyramid. So our perimeter we found was 216. Our slant height was the square root of 2736. If we type all that on our calculator, we're going to get about 5,649.13301. Keeps on going. So we're going to round this to the nearest square foot. So this will be 5,649 square feet for the lateral area. So the area of those 6 triangles that go around the edges of the pyramid is 5,649. All right, so lateral and surface area of a cone. So in class, I will show you where this formula comes from. It's kind of neat to derive it, but it's hard to do in the little space that we have here. So the lateral area of a right cone is half the product of the circumference of the base and the slant height of the cone. Notice we're still talking about right cones and right pyramids. So if we need to make sure that we have regular bottoms for our polygons for our pyramid, and that the circle, the center, from the center is where it's drawn straight up to the vertex. Okay, so we have to have a right cone to make this work. So we're going to get the lateral area as 1/2, okay, times the circumference times the slant height. You could just think of this as the same formula. That's the perimeter times the slant height. But if you work out the 1/2 and the 2, you can shorten that formula into pi times the radius times the slant height. So the surface area of a cone is the sum of the lateral area, that's that pi RL part right here, plus the 1 base, which is a circle. So you'll see this shorthand a lot like this, pi RL plus pi r squared. All right. We have an example down below for problem number 3, finding the surface area of a cone. The radius of a cone is 16 meters, and the slant height of a cone is 28. So this length here is 16, and this one is 28. What is the surface area in terms of pi? So our formula for the lateral area of a cone is pi RL, and the formula for the base just has 1 base, so it's pi r squared because it's a circular base. So we're going to put r in as 16. That's our radius. And the slant height is 28. And then we'll put in our radius as 16 again. So pi times 16 times 28 will give us 448 here, pi. And this will make 256 when we square 16. If we add them together, we get 704 times pi. So the surface area of the cone is 704 pi meters squared. Okay, so we had to find the whole surface area, which is the lateral area, pi RL, plus the area of the base, pi r squared, because our base is a circle. All right, so one more time to walk through it. First, we used our formula, lateral area plus base. Then we substituted in for lateral area and base in this with pi RL and pi r squared. And then we plugged in for r and L and did some simplifying. All right, let's flip it over and take a look at our last page. Okay, problem number 4, finding the lateral area of a cone. So all we care about in this case is the lateral area, not the whole surface area. So what is the lateral area of a traffic cone with a radius of 10? All right, so we know our radius is going to be 10 and a height of 28. So there's the height of 28. We're going to round this to the nearest whole number. So we're going to let L be the slant height. We don't know what the slant height is, so we'll put an L there. And label all of our dimensions. So we have 28 for our height. The height of the cone, remember, is through the middle at a right angle. This is a right circular cone. And the radius is the radius of the circle base of the bottom of our cone. So we're going to use the Pythagorean theorem one more time to find our slant height. So that's the hypotenuse of that inner triangle, because there's our right angle. So we're going to use 10 squared and 28 squared here. 10 squared is 100, and 28 squared is 784. So the slant height will be the square root of 884. Now we're going to use the formula to find the lateral area of the cone. Our formula is pi times the radius times the slant height. Okay, and that's going to give us pi times our radius was 10, and our slant height was the square root of 884. Okay, if we type that on our calculator, because we're asked to round to the nearest whole number, we're going to get 934.0626, some other stuff. And then we round that, we're going to get 934 inches squared. Okay, so this brings us to our lesson check. As always, pause the video and try the lesson check yourself, and then come back and see what you understood. Okay, welcome back. So our lesson check. How are the formulas for the surface area of a prism and the surface area of a pyramid alike? And how are they different? Okay. So remember, a prism has 2 bases with rectangles all the way around, and a pyramid has 1 base with triangles all the way around. Okay. So how are the formulas alike? Let's see. All right, so prism, let's go through our list. A base is a polygon. This is going to be in both lists. Okay. For both prisms and pyramids, we have polygon bases. Prism has 2 of them, but pyramid only has 1. All right, our second one, the faces are rectangles. So these are the lateral faces, and that's only going to be in a prism. Remember, the lateral faces for a pyramid are all triangles. So see here, faces are triangles. That's going to be our pyramid. The surface area is the lateral area times the base. So we only have 1 base here. So the lateral area is all the triangles added up, and then the base is the 1 bottom for our pyramid. And for E, we have the lateral area, which is a bunch of rectangles added up, plus 2 bases. So that's going to be our prism. All right. Uses the height. So for F, we're going to need the height for a prism. Okay. For a pyramid, we need the slant height. So that's going to go here. But we need that perimeter for both. Okay. All right. So perimeter is going to go in for both. So how are the formulas alike? They're alike by the fact that they, let's see, what's the same in both? So we need to know the base, area of the base, and we know that they have to know the perimeter. So they are alike in that we need the area of the base and the perimeter of the base for both. And then how are they different? Well, they're different in using height versus slant height. That's one way they're different. Okay, and they're different in their lateral areas. One of them uses rectangles and the other one uses triangles. Okay, so that's going to give us a different lateral area formulas. All right, so check off the vocabulary that you understand. Hopefully you know what a pyramid is by now. You know what slant height is. Lateral area hasn't changed, surface area hasn't changed, but we did talk about a cone today. So these are our two new shapes, pyramids and cones. Okay, and then we use slant height today as a new measurement for cones and pyramids. So as always, if you're not in here, you probably want to watch the video again and make sure you do some good learning before you come to class and start trying to do some problems on this.